Is anyone else on that?
No, but I posted the link to on the Diagnostics Summit issue, and we'll have a recording. And so if anybody externally wants to kind of watch what it is we're discussing, they can watch it. And if you know, they can certainly watch it live, and I think they can chime in with comments. So, what did you guys want to talk about?
Diagnostic channel.
Well,
You started it.
I thought we had an agreement and resolution, didn't we? No.
So what do we do?
So one of the things is like,
steps,
are we starting fresh, forking the existing one?
Does it make sense to collect the requirements from APM?
Yeah.
I think
Because I think it's a little bit strange. We now have a solution to a not really defined problem. Yeah, at least for me.
Yeah, sure. So I think that we can certainly do that. We can talk about, you know, fork or start fresh, or, you know, use the existing stuff, or all of the above. You know, we can try and get to a concrete step. So
what does it do? Can we really quick talk about
the diagnostic channel?
Yeah, about the architecture of this.
Yeah, I mean, I'm going to, you know, I'll speak to what I can remember, and I'll make up what I can't. So
okay.
No claims on the accuracy or truthfulness of any of this. But it's effectively what we had talked about, which is that, you know, there's and, you know, people feel free to look at the code and correct me if I'm wrong as I'm speaking through this. But there's sort of a pub module, right, that somebody can take a dependency on and then write data to this thing. There's a subscriber library that lets you listen to that data coming in, and then as the data is written, I believe it will synchronously, you know, notify any subscribers and, you know, fire a callback for those subscribers saying, hey, this stuff is happening, right? It does some current monkey patching to propagate context across some user space queuing points, which is something that can potentially be, or should probably be, filtered out.
Yeah, that was that was bothering me a little bit. The sensors that are built in now, like MySQL and MongoDB and everything, I think this should be, this is kind of, is against separation of any concern, because then we have everything thrown together, and every time we have a new module, we have to put it in, like, create the instrumentation in there. So that is something I would really strip it to be just this pubs up thing, and then the APM vendors can build something or do something with that.
But wouldn't that also defeat the purpose of having to only do it once?
No, you can have one model is the publisher for MongoDB, and one model is the publisher for MySQL, instead of one big model.
Okay, I thought you said that then
then you can show it out, but now it's like everything all in one.
The benefit of putting it in core, if possible, right, this thing, or making it a core sponsored initiative, whatever, is that given this is the last way to do this type of thing, we can then send a pull request to MongoDB, to Redis, to wherever it is, and then add that support within that library itself without having to Monkeypatch completely.
Yeah, that makes sense.
And the advantage of having just one standard publishers module is that, in theory, that module shouldn't be growing and growing. In theory, that module should grow temporarily and then shrink again, and hopefully one day be just an empty thing that does nothing because all the libraries are actually native.
So that would then, what's in there would be a shim, more or less.
Yeah, so the only thing that right now has basically the shim for the actual instrumentation and the libraries.
Okay.
Sorry, so what does it do? Sorry, so I'm trying to think of what I said. So
I think what Jan was just suggesting is, like, we have, or actually multiple were saying it's like 2 modules, one that does sub one, and that depends on this module and does all the Monkeypatching,
Yep.
it'll grow temporarily, like you said, and then hopefully when all the modules adopt the underlying concept thing, then the one that depends on it will just go away because it's not needed anymore, right?
Yeah, and I think that's the current structure of the code today, if I recall correctly, is that I think there's a publisher module, a subscriber module, or maybe they're both in one, right?
One at this point.
Are they?
Well, the
Okay.
one that's in are they also?
But it's different. Oh, well, maybe.
It's one. I think there's one repo with multiple
Yeah,
modules.
they have individual packages.
Yeah.
So it's different packages.
And then there's another thing that actually goes in and does some of the monkey patching, right, and spits out some data, right? I think that if I remember correctly, it's doing some context tracking using zones, right?
It abstracts away the context tracking
So
from my glance of the source code. So
Okay,
it allows you to.
you know this better than I do. So go ahead.
It allows you to add a context preservation function, which is just a function taking another function that you can use to bind function calls or function implementations to the context. But it apparently allows you to basically wrap multiple of these that are then nested call. So it is not dependent on zones, but you can use it with CLS or with zones or whatever you use by setting it up
Okay.
with your context propagation technique.
Why are we? So is this thing supposed to be based on top of something like async await? So async await, async hooks?
Well, I think that there's a question about how context is tracked, right? And I think the current state of the world is such that this module needs correct asynchronous context tracking, so it has it implicitly built in. Now, if there's some other library that it could take a dependency on that kind of says like, hey, I've solved the async context tracking, whether that's async hooks or something else, right? Then, I think this module should rely on that. But in lieu of that, it has to do something, which is why it's done the way it is today.
I guess one of the requirements, I think, which we haven't discussed is that I think APM vendors want to support Node 6 and Node 4. So we can't rely on async hooks.
I would not be concerned about that.
So I guess the question becomes now that if this is something that core is going to bless, then core actually should take async hooks is what this is based on. And that could be one way to go forward. But
yeah, so considering the way this type of things progresses and becomes available for public consumption, this might take several months to ship. So it's fair to say that by when this is mature enough to be used widespreadly, Node 6 would be gone away.
No, not really. We still see Node 0.20.
Maybe from your support cycle, but not from ours.
Yeah. Okay. That's it's if you still support 0.10, like it's.
But anyway, I think we should not. I think this is a secondary problem because anyways, also the implementation of third-party modules will take a long time.
That's yes.
Yeah. So there has to be some very long period of transition, and we have to face that. Yeah. I would not say this should hinder the solution, or somehow reduce the scope of what we are aiming for.
Yeah, I mean, the worst case is if nobody registers a context preservation function, then the default is identity. So worst case is that some modules might do some technically unnecessary calls to an identity function that I'm assuming would be the optimized way for the most part. So
What is that?
But normally I would expect that already today most of the modules have something like context which they associate with a transaction, with a request. Yeah. So either module has such a mechanism which it simply can use to continue the context that is already there from the beginning of the operation, or it can use async hooks.
Yeah, I think a lot of that's like what you're actually going to do is going to depend on the runtime you're targeting. runtime you're running on, right? And I kind of feel like, for this to be successful on down-level runtimes, we're going to have a solution that manages the, asynchronous context traffic.
I think we have also to distinguish this. One thing is, for a database request, we have to extract data. So we definitely need some sort of callback in the beginning. We need some sort of callback in the end.
Mm-hmm.
So this is the one side. And if you have a callback in the beginning and in the end, then tracking also the context is in the end not a big deal because you have associated data already.
But you do that by wrapping a callback that's going to receive the data, the user's callback.
That's a layer below, which we target to actually implement this. We have a MongoDB request object or whatever. This is already there. So they have their context object. So sure, we can rely on async hooks that maybe they drag the context the way we want, but the driver has already its context. The driver knows what
so I think that's different. So the request object that the MongoDB library uses is not the context that we mean in this discussion, I think. So there's two different kinds of context.
I'm not interested in the context of the lower layers of Node.
Well,
I'm interested in as a database request that starts here and ends here, and this I have to link.
But is that a synchronous? Is that a synchronous call stack that's
no, it's
unwinding?
It's already defined, and the corresponding callback. This is what we have to link together. And
okay. So then you've got two different, synchronous executions, and you want to capture the CPU time on one synchronous execution, the CPU time on the second synchronous execution,
and the wall clock time between.
And the wall clock time between, and that's the data that you effectively want. And you achieve that by monkey patching the Mongo driver API, capturing the callback that gets passed in as a parameter, wrapping that up in your callback that's going to basically say, like, I know that now I got some data back, and I know when the function is finished executing, and I know what to do.
So if MongoDB uses 1 or 2 or 3 TCP connections below, or reuses the same connection for a lot of requests, we don't care. And this is in the end the main problem is async hooks. Async hooks do care about this. They don't care about the high-level transactions. They care about the low-level stuff. If you write also one TCP connection, get the answer on the other one, async hook says, not any relation. But for us, this is the relevant relation.
Is it what you're saying that actually the module also, like MongoDB, for instance, they have a way of carrying through the context?
Sure, they must have. So if you think about Redis, you have one TCP connection, and you send some data in, the data stream.
Again, they have to know what callback to call.
And there's a transaction ID plus Redis.
So they could pass through a transaction ID if there was one.
In the end, they have to know this because
they have
to call the right callback.
Yeah, but from an instrumentation perspective.
If I have two MongoDB requests, and I pass 2 callbacks, at the end, MongoDB has to take care to invoke the correct callbacks for the associated operation. So they have something that they transport from the synchronous to the asynchronous execution. And
so
they can leverage on this.
I think the thing that's not clear with me is, like, does this notion of context that you guys are talking about, is it addressed by this discussion of async context and this definition of async context that we're also trying to drive, that we're going to talk about later, right?
Sure.
And,
but this is then when it comes out of MongoDB. We want to be sure that the same context then goes into the next database request, so that we can link these together.
But I feel like we're talking about 2, maybe even 3 different things that might and might not be related. So one is, I think that's kind of what started the whole thing, was how do we get information about the database request? Which database server did it go to, all that stuff. The other is that some database drivers, because they use a pool of connections, they have their own callback queue, which means that we can't trust that async hooks is working, or we can't trust that our own normal monkey patching on the core is working. I mean, it is working, but it's just not capturing that part, right? Because the place where the callback was queued is maybe the same time as the pool was initiated, and that's not necessarily when the callback is then called later. And that is fundamentally two different things. But of course, we as APM vendors, we all solve it in one go. We solve it by saying, bind this callback to the current context, and by the way, let me know when it's called because I want information about the result. But it's actually two different things. So I wonder if it's necessary to solve them together.
Yeah, but I think that's what this channel thing tries. So it solves a few things that most probably, if it's implemented also on the module vendor side, we maybe don't have to solve anymore. But that's
well, it should really be two different things. Like there's the data channel. We want to know like this function was called with arguments has these things we care about, and then the context tracking is something totally different and not valuable in totally different ways. Like you can use that just as a regular developer to like pass stuff around in your application, just like local storage. But like if we split those concepts up entirely, like, we can just have the data channel. Like when we get an event, like we can look at our own context local storage inside of our agents. We can each use it however we want, and like the module instrumentation itself doesn't actually care about what context am I in. Only we care about that.
Yeah, but that's the point.
Connection pooling and stuff like that.
Well, but I think
That's why like if there was like an API that they can provide a hint that like yeah this is going to break continuation, then like they can keep their context linking, but that's a totally separate thing from the supplying data. There can be another module that is like my thing will break context continuation, so I need to link the callback to the call. That's totally separate from the data. But I kind of like having the hey, this module needs some kind of Monkeypatching and or expansion in some form to work correctly in a typical diagnostic tracking scenario. Having that in one module, even though I totally agree that context tracking and extracting data from API calls is two different concerns, and it feels kind of dirty to have it in the same module. At the same time, both need the same and kind of, in many cases, the stuff that you need to monkey patch to get those two things to work tends to be the same thing.
Yeah.
So by splitting it up, we just risk double monkey patching every single API, which
like
seems
you can expose one module through another. The context continuation could be its own totally separate thing.
and then
So
just
if
use
someone
one
only cares about maintaining continuation, then they require that. If they care about both continuation and diagnostics, you just have an extra thing to link the function, but it actually just calls it something in the background.
And on the other side, we could also start with one module to have a simpler starting point, and then split out if somebody really asks for the thing in isolation.
So one of the key discussion for this is get out of Monkeypatching, right?
Yeah.
Are we talking about Monkeypatching right now?
It is, but I think what we tried to do is we tried to scope it to kind of focus on this sort of getting data out of these API calls versus monkey patching for, asynchronous context tracking. I think that getting the data out requires context tracking, right? It requires some sort of well-defined semantics about context tracking, and it requires well-defined transition points or continuation points, right? I think that that's useful to a broader set of applications and just getting data out of these API calls.
It's not just about taking data out of API calls, because what you want to maintain is every request comes with an ID to some extent. We track through all the flow. So you need a way to put that. You need to put that ID somewhere.
Yep.
Okay. And then you have that ID is being even so that extracting the information needs context tracking.
The data without context is worthless.
Yes.
Just a chunk of data
So,
out of nowhere.
Yes, context is required, context tracking is more generally applicable than just this getting diagnostic data out on a, on a pub subchannel.
So, but the other way around, you could definitely use a module that just makes sure to bridge those async gaps. But you don't care about the result of database query. You just want to make sure that the other part is taken care of.
And moreover,
that's a standalone module I could see a lot of people for.
I would actually say the same thing of the data channel as well. Like the data channel, the context is useful for us as APM providers if we want to provide a structural trace, but it's also useful with no context at all. Just like, for example, if you have like a Lambda function, like it only does the one thing. You're not trying to differentiate between routes or anything. Just it does this one thing. I know what it's going to do. I just need to be aware that it connects to these 4 services in the one thing it does. So a contextless data channel in that perspective is useful. So I think just having pure data channel, pure context, and then like a thing that can layer or connect those together.
Yeah, I wonder how, it's like having no context, like in the Lambda case that you mentioned, is the same as having a single context in the Lambda case, right? And I question how useful it is to have, a data pub sub mechanism without having it built upon some notion of context.
Also, do we want to risk ending up with 50% of the modules are instrumented with one or the other, and 50% are maybe with both?
Yeah.
I think to me, it seems
it'd only be instrumented to like broadcast data through the data channel, and like if it has continuation problems, they can fix that with the continuation.
Yeah, but the problem is that
like
you need to have 2 different people sending the PRs and 2 different people explaining what this library now does. Whereas if you have one, this is our baseline of a well-instrumented library, then in theory at least you only need to send 1 PR for every library instead of just convincing them of taking on dependencies from 2 libraries.
Yeah, but I think that the argument for actually separating these things out is that the approach for how you're going to do context tracking or continuation tracking is going to be runtime dependent. That is, if you have a facility like async hooks, you can leverage that. If you don't, you have to do something else, right? If you have some, async hooks plus, you can use that 2 years, whatever it is, right? Whereas the diagnostic data that's coming out is module version dependent, right? And I think that's kind of the distinction, right? And how you should be able to compose those things sort of independently, right? Which is why I would argue against merging them together.
I think there's a way to allow composability. So by providing a way to bind the context, being the API doesn't necessarily mean tie you to a particular context mechanism. So I think Jan was saying earlier that, in the worst case, maybe I'm using async hooks, I don't need anything, in which case my context bind function would be the identity function. So I think it's possible to decouple them, but I think it's seeming clear to me that a mechanism that says bind to the context, wherever that's coming from, do that. I think that seems needed.
To me, it seems this should be the foundation. Right? I don't see any of that working without a way to track context. Like it's not. I don't see it as feasible without it. The data might be. You might get some data, but you might get data like, oh, I'm doing a request to a database, okay, and then the data that comes out will be. Not so you can know when that database transaction has finished, but then you don't have any other way to communicate what's going on to the next callback.
Yeah, I agree. It is absolutely required. I think the question is like, what's the best way to factor structure this functionality?
Yeah, it seems that this should be a longish term solution to some extent, like the context preservation function, the way we implement the context local storage, whatever you want to call the stuff. It seems a functionality that's very very, very needed in a lot of cases. And async hooks do not provide that functionality out of the box.
Yeah.
Like that's to be said. It's not the identity function. Async hooks is even lower level than that. Okay, let's be very precise on this because it's important. So what you want when you're saying we want to standardize the diagnostic channel this way, you're actually also saying we need to standardize the context local storage.
Well, a context preservation function.
Context preservation, whatever you want to call it. I'm not like it's fine. Like it's a thread lock out for Node. Sorry to be
But in terms of this API, though, it is effectively just a bind function, and somebody can plug in something that says like, hey, I want to use X or Y or Z. They can plug in a provider, if you will.
Yeah, and it's not a complete context cracking mechanism. It's a way to plug the holes in whatever context propagation methods people generally use. So, for example, if I'm assuming that the bind function would basically be used in the superset of all the possible gaps in context cracking mechanisms that are in use in the versions of Node that we support. Yeah.
Actually, it's more than just plug the hole. It's giving you the right level of abstraction, right? So I could be using a low-level mechanism that's just not at the right level of abstraction. I just don't care about what are the things you did. I only care about what was the express service request you accepted. That's my transaction. All the internal ones I don't care about.
But shouldn't the, for example, Mongo, shouldn't they call the providers API based on hooks? Don't care about any bind thing, because as long as they do that, then we will get it through the normal hooks that are applied in async hooks.
So yes, the answer is yes. The async context will be propagated, but you, as a consumer, you still have to go find the right. You have to walk the link or cause or trigger chains to figure out where was the request actually initiated, right? So typically what I would expect people would do is have a concept of a higher level context, and this is what this context preservation function is propagating. It could also do more things. It could also paper over, plug in the holes where things don't work. But that's just, you're saying there's a low level mechanism that wasn't working, so that's why I need to bind.
But these holes, for example, in generic pool, I thought the whole point of making async hooks so low level was that the whole point about making the providers the embedders API was so that these places call this API to plug their own holes using async hooks.
Right. So in the future, we won't need to plug the API for let's say some user space queuing library. But for Node 6, running a version of connection pool library that doesn't support, you still need to plug in the gap somehow.
Yes.
So we have that function. Plug in that will just like
So even if it's set, okay, this is only for Node 8 for stuff that supports async hooks, that would of course not give us any context tracking. That would just give us the events needed to build context tracking on top of. So if you want to have a context tracking mechanism that the APM providers and others can share, we will need to put that into core, standardize that in some way.
It needs
and that context tracking mechanism is then the same no matter if you have hooks fired by async hooks or if you have hooks fired by some Monkeypatching. Or they all go into that.
Probably can't be in core for exactly that reason, but I think it's something that should be some form of
supported by core, right?
Supported by it should be some blast.
Yeah.
And not a shared effort, so that it's come from core, but it might be in core if possible, but I don't know if that would be.
But in any case, it's something that needs to be developed no matter of async hooks or not.
Yeah, that seems my understanding. It's something that
because async hooks doesn't support the people this functionality.
Yes, exactly.
That's way more loaded.
So it's
But from the async hooks as embedder, I can define my own async operation.
Yeah.
So question for me is, does it really fit? So if I have async hooks on a low level and I build a new async hooks interaction on top of it, which one is then the truth? So if you consider, for example, we are the users, we are interested on the high level, we can then find Mongo find and the corresponding callback.
Yeah.
Our ID matches. Okay, nice for our use case. Someone else creating a model for long stack traces, which means before every callback they take the call stack, but then they have on timeout function take a call stack, and later on they call the callback of Mongo find, where they find that again a call stack done. Even there is no asynchronous interaction in between.
So I guess you would listen only for the resource that you care about, right?
Yeah, but who knows the resource?
So I think there's
the resource is just a string. You can have unlimited resources.
You can if you scope it under the module name. Then I mean, it depends on how long you would use the.
Yeah, but if you consider you create the long stack trace model, on which models you listen then?
I think that this is sort of hinting at the problem that we lack sort of a shared definition or shared understanding of async context, right? And what does it mean? I would hope that we can get to something where.
What does it mean for whom and which level of async context? Who cares about? I think that's the thing.
Well, what I would hope is that there is eventually a library that lets you, building on the stuff that Mark was talking about, we're going to talk about later, right? That gives you a model that represents your asynchronous call flow that somebody can traverse, right, at runtime to solve this class of problems. And moreover, that's something that can be, monkey patched into down-level releases, right? And that's something that can be implemented on top of some, lower level primitives on, more current releases, right? But that there's a shared understanding of what this means, and it is intuitive and it makes sense and it solves these problems. I kind of feel like, the key takeaway for me here is that 1, async context is hard. 2, we don't have a clear definition of async context. 3, the diagnostic channel and data publication requires this understanding, right? And lastly, we're rat-holing on async context rather than talking about, well, how do we publish this data out? Let's assume we've got a mechanism to track. Let's assume that that's there. We'll focus on that thing separately. I think Ali pointed out that we need some bind function to kind of fill some gaps, right? But if the primitives are there, if we've got an abstraction level that's there, and if we agree upon the correctness of the model, then we can move this forward. Is that a fair summary?
Yes, it is. But without that thing in place, starting implementing a diagnostic channel is not.
So we might have, inverted the order in which we're talking about things. I think next.
I don't think context is actually exactly required for diagnostics channel. Like for our use of it, like we care about like what request you're in, what things have happened in that request. But like currently, all of us implement that ourselves to some extent, and our instrumentation of things, we gather all of this information synchronously in our code. We know what the context is. If we just have like a synchronous data channel, like just diagnostic information, if that's synchronous too, we're going to be in whatever context our own context tracking stuff is defining. So the data channel itself doesn't actually need to care about that. It just needs to emit the data, and we just listen to it and say, like, I know I'm in this request right now, so I can connect it to this.
Right, and I think
so that the context tracking thing we can think about totally separately.
Yeah, and that's been my intuition, right? Is that that's the case. I do think that the correctness of this is predicated on having a correct, context tracking mechanisms in place, right? But I do think that can be slayed as a separate.
All our definitions of correctness, though, I think vary a bit.
Right.
Like some people don't care so much about the internals, others might. It depends on your use case.
Yeah, I think this is the main problem, that it depends on the use case, what is right. There is not just right and wrong.
Well, again, it's like I think that there's, we can talk about it in a few minutes, but there's a proposal for a model that the argument is that it is sufficient to represent what needs to be represented for asynchronous context tracking, right? And that model, assuming it's correct, right, is the way to think about things, right? Now, if there's a hole in it, let's fix the model, but let's focus on the model, right? As opposed to saying like, well, I've got my definition, you've got your definition, I'll take mine and do my thing, you take yours and do your thing. That's been the fundamental problem, I think, with trying to get to some agreement about what does asynchronous context mean, right?
Sorry, I want to. That's very bad. In some form, to get the source of the root problem is get out of Monkeypatching. Right? And I just want to keep the focus here because I love the model discussion. And I'm not saying it's. I think it's work that needs to be done. But the major problem here is that we need code to do this stuff.
Yeah.
Okay. Like the work in an output, a tangible output of that model discussion needs to be a way, an official way to track context out of Node. But then this thing can be layered upon. If I understand this,
not if you care about pre-version 8. If you only care about versions of Node where Async hooks is in, then Monkeypatching is.
Yeah, I mean that's his timeline, right? So starting with version 8, if all the libraries correctly participate, then the Monkeypatching stops in its timeline.
Well, it is the question, like, do we need the model if we are past version 8? Like, is async hook enough to model asynchronous interaction in all cases? This is a question mark that is still open.
Yeah, and I mean, I would make the argument that, again, I don't want to diverge into the whole async context discussion, but I would make the argument that async hooks needs to, adopt some notion of, formalisms or some notion of a model, right, that's a little bit easier to reason about than its current form, right? And, when that's in place, right, then you can look at how do you backfill that on the down-level revs, and how do you then expose that in a consistent way?
Yeah, so I would say on that topic that, at least from my perception of the discussions yesterday and today, there is a fairly broad agreement on the definition of, in the model, the link edges. And as far as I'm aware, the link edges are what most async context, continuation, local storage, whatever you want to call it, mechanisms use is link edges, which is the thing that most people agree on in terms of the broad definition. And it's the thing that at least things like CLS hook use, and as far as I can tell, there's pretty much a one-to-one mapping between the link edges in the standard model and CLS hook. Like that is how CLS hook works in general. So I don't think that for the usual APM tracking the transaction context use case, I would not foresee any major revisions to async hooks unless the model and async hooks both change fundamentally, which seems fairly unlikely. There's definitely something to be gained from the other elements of, like the resolved edges and the caused edges and runtime APIs to traverse. But for example, if I want to read from the continuation local storage, I don't want to traverse a tree to do it. Like I want to have an O of n, O of 1 lookup from an object that is immediately accessible. So I'm not sure that the lower level API of there's a tree that I can now walk with my async call graph would actually help me for that use case. So the library implementing something like configuration over storage wouldn't necessarily expose those details. So it wouldn't necessarily influence the typical user of the diagnostic channel. That's my gut feeling right now.
I just want to introduce time.
I think we're pretty close to like when we should switch to the next one.
We've been on the next topic.
We're very close to the next topic.
There is a question mark.
So actually, what I was going to say that the topic of async context will take in if you were given an infinite amount of time, I think you could spend it on async context. I think we've been talking about exactly that pretty much for the whole session here. And the thing we didn't talk about was, I mean, assuming, like back to what Matteo was saying, and back, I think you were alluding to, assuming that could exist, and whether or not that's ideal or we could improve it or flaws or whatever not, assuming that could exist, what do we need from the diagnostic channel? I think that's what I really wanted to focus on. I think that's something that we didn't do.
I agree. We probably, given time, we probably should, transition, like other people who want to be involved in the async hooks thing should probably come in. I don't know if you want to come in. I'm just going to keep this broadcast going.
Here, profiling the other one.
Yeah, let's see that.
The question mark is, do we all agree that for whatever functionalities this diagnostic channel work will do? Do we all agree that this magic bind function, context tracking, whatever it is, it's needed?
Yeah.
I don't think we necessarily need to answer that one.
Needed for what? Sorry.
To implement successfully implement diagnostic channel without Monkeypatching.
So I would say I don't think we need to answer that one. So the question is, I think the other questions are more important than this one.
I feel it's weird to confuse Monkeypatching with that, because Monkeypatching is only needed because we don't have async hooks previously. Monkeypatching needs to do two things: to as an alternative to async hooks versus that we don't have async hooks, and to get information about when an outgoing HTTP request is made in your core, and when an incoming HTTP request comes, etc.
Or for a third-party module.
Or third-party module when Mongo makes data return. So it's needed to get that information, but async hooks takes care. Async hooks with a little bit of sugar on top takes care of, which is not Monkeypatching. That sugar is not Monkeypatching.
Yeah.
It takes care of the context.
Can it take care of the other?
Which it's what I'm trying to say. Like async hooks does not currently provide that functionality.
No, and it doesn't need to.
Yes, but in order to implement, if we want to implement this in core or in the Node project as a thing.
So when you say this, what is this? The
diagnostic channel.
Okay.
You need a way to preserve the context between.
So actually, so the answer to the question is no. We don't strictly need to. I think it can be convenient in some cases, especially if you are backporting. But async hooks alone is probably adequate.
That's
the context is not actually relevant to the data that's being emitted from the channel. Regardless of what your context is, you're still emitting the same data. The data channel, we just need to know, like, yeah, a HTTP request happens. We want to know what host it's going to, what's the URL, that sort of thing. At that point, it doesn't care what the request is.
Yeah,
anything about the content. It's only when we go to consume that information that we care about what the context is.
Yeah.
In which case, we can have context tracking being some totally separate thing. That we receive this data and then we pin that to our context, whatever way we decide to.
So getting that data and figuring out the context, do that in the same part of the code, right? In a single function, you can do both. And that function can be like the before and after callbacks. Hooks for async hooks. So I mean, async hooks is like a abstraction over that, right? Where it's just a place where you can get information.
The async hooks before and after callbacks you get before. So if you consider MongoDB find this example, the before and after callback you get for the find callback, not for the find call. the find call may create some new resource, you get the create call.
Okay, so you
It's not the before after. So we
look as well.
you need to go on this.
So let's do this. I don't want to like be a bulldozer here, but I think time constraints. We probably need to tell other people we're transition to the async hooks, async context discussion, even though that's what we've been talking about for the last.
I think Mike just went in and did that.
Did he? Okay, great.
Yeah.
We should probably take a couple of actions in terms of how do we move. Assume async context tracking is present. How do we move the diagnostic publishing stuff forward? And what do people want to do without diving into the whole async context?
Well, I think that actually there's the discussion whether the events could. So, for example, MongoDB does the find call. I think I finally understood something that Ali said half an hour ago. So in theory, the find call could use the embedder API to create an async hooks resource with a name for that higher level operation of it's a MongoDB find, and use the normal init, it started the function, then before, after for invoking the callbacks or whatever the exact semantics are. And an API vendor would only need to consume async hooks to also get higher level operation resources that don't technically require async hooks for context tracking because they are already covered by context tracking, but would model these operations using the same semantics and the same APIs that async hooks is using. Which, assuming that most of these operation or events are to some degree async and wouldn't just fire all the hooks one after the other anyhow, because it's just one event. So for example, server listen, I'm not sure if that would be in single event or whether server listen would be then the server is the resource and listen is, I don't know, right? So there's some weirdness for actual instant events, whether those can be modeled using async hooks in any meaningful way.
Are you saying that stuff in Diagnostics channel can just be async hooks can function as Diagnostics channel?
That's the question I heard in the room. I'm not sure if I misheard.
The question is, in order to implement this method of diagnostic channel, do we need something shared between async hooks and this library? Is there a gap?
Are you asking, is it necessarily required or is it convenient? So, necessarily required, I think I would say the answer is no. Convenient? Yeah, it could be.
But this is an important. So, is this diagnostic channel useful without any context?
So there is context. Async hooks, it's an order of n lookup. That's why it could be inconvenient. You may have to walk up a chain to find, oh, this is the outermost HTTP request under which all of this lies. It's work, and it's not convenient to do it, but async hooks does give you that.
Also, I want to point out that not every application is an HTTP server that has transactions, right? So that Node applications that might just run as a process, and they have no transactions. So context tracking might be way less important for them.
So for a given domain, right? So for APM domain, or for you're writing some other tool, right? For that given domain, you have to understand what your application is and how you're going to present data about that application, right? So you have to understand what the model is, right? So for the APM use case, whether it's gRPC server or HTTP server, the APM knows that actually for these servers, I know how to present data to the user. For other use cases, I think the tool writers need to decide what they're going to present. But ultimately, there's an outermost thing that happens in response to other things happen. So, I think async hooks does give you the essential tools to async hooks or tweaks of the async hooks model using the model that Mark was presenting. Like if there's whatever that model is, those give you the tools, and you don't need a notion of context on top of it necessarily. But as a convenience, an APM vendor or somebody else could build something, but that's not a requirement.
This is a good answer. And it's an answer as good as any. This was a question mark that has been floating around for. This is one of the key. We started at this point where we decided there was this fact that diagnostic channel provided the current implementation of diagnostic channel from Microsoft provide a context preservation function as part of its working, and we have said we don't need it. This is
don't need it as a requirement, right? So I could see it being convenient, but it's not a necessary.
Here's the thing: it's either in the code or it's not. So it's either in or out. Like there's no gray area.
I think this is not the most important question right now.
It's not part of what the purpose of the diagnostic channel is,
Can-
which is to collect data. It has a different purpose. It's useful to the channel. Like,
Do we need it to be working before implementing the diagnostic channel? Can we start working on this without the other one? This is the question.
I think we can start working on other stuff without this. I think this is a red herring.
Yeah. I don't think it's the most important part that we need to talk about.
Yeah, that's fine. That was where we stopped and we discussed, because it was not.
So I think in terms of like time, we should probably move on to the async context discussion.
Which we never.
We can talk about for 30 minutes. But
that was very important.
to wrap up the diagnostic channel stuff, I just want to reiterate from Microsoft's point of view, it's like we're interested in getting to a community solution on this stuff. We don't want to be monkey patching everything, So I think we talked about using this diagnostic channel thing either as a start, fork it, write your own, but let's somehow try and figure out a way to drive a conversation around how do we move this forward.
I would say let's start a new project within the foundation offices, and we can use the diagnostic channel as a guide and a straw man.
Sure.
Let's just do it that way.
Okay, that's fine. Are people in agreement with that?
Licensing is easy because we're under the foundation under the Node copyright. So
sure. All right. Did anybody get a picture of the board?
Yeah, take a picture of my ramblings. I don't know.
Well,
I think it's
Yeah,
useful.
put a question on the board. I'm very happy about it. Put a question mark, yes. Impossible? Yeah. This is a question mark. This was another question that. That's the question. This is impossible to trust Async Cooks because of internal pools.
Yes.
Yes. Perfect. How do you feel that? That was.
So did we agree on the next step on this?
I think we're going to start a project in the foundation with the goals of where the stuff can land, use diagnostic channel and sort of the starting.
So the diagnostic channel doesn't have consumers today, like users,
Okay. So do we want to move on? We got a photo of this, and we're gonna. So for anybody listening, we're going to talk about async context,
which we have been talking about already.
let's talk about async context finally.
Again.
So I think one of the things that we wanted to talk about. Mark talked about the model yesterday, which is kind of a formalization on these things. I think that there's a number of questions that some people had. We wanted to have some time that people can kind of dive in on this stuff in detail, poke holes at it, quibble with terminology, quibble with the thinking around it. But the end goal is get to some kind of shared understanding, shared vocabulary about what asynchronous context, asynchronous call flow means, and try and use that to sort of that shared understanding to move some of these forward. So when a time just for people to ask questions about this stuff. I don't know if people want to continue some of these other discussions that we were having, or people wanted to focus in on this, higher level abstraction. Yeah, please go for it.
Yeah.
So I assume silence is agreement, and.
So I wanted to ask.
Okay. Yeah, that's what I thought for the last 30 minutes of monkey patching discussion.
Kind of related to what you're asking about I wanted to like clear up something. Like if I had like a module that whose purpose is just makes a callback and waits 1 second.
Sure.
So the module exports just like wait 1 second and then
I'm not sure this module exists.
It's on NPM, and if you take it off, it'll break the world.
Then you have wait 2 sec, which is a separate module that depends on wait 1 second. And so why did I talk about this?
I think I know where you're going with it, though.
So the division between client and host, right? Like how do I know?
Where does the link event occur? Right?
Maybe this was their method.
Well, does it have one link event, or let's say one context event?
Yeah.
Right. Or does it have 3?
Yes, that's it. Because I mean, wait 1 second. I guess underlying invitation is just a set timeout, right?
Yep.
While wait 2 seconds, the underlying event or the underlying thing could either be considered 2 set timeouts or 2 calls to wait 1 second.
Mm-hmm.
And so if set timeout and wait 1 second both use like the link function, right? Then we get relinks to 2 things. That
Yeah. So I think this is an excellent question, and I don't think we have an answer that I'm entirely satisfied with, right? So because the issue we say is the question of what is the host code and what is the client code, right? And it's very, at least to me, it's very clear if I look at the Node core modules, right? I look up in the spec, it says the client can call this and it's async, and the client is all the other code and the host is Node core, right? So for set timeout, the answer is very obvious. I want to show you one event when you set timeout, and I don't care how much happens internally. I'll show you one. The challenge is in the embedder API, if I have the embedder saying I'm async and trying to present one boundary, and that has another boundary with the host, or even more challenging, I have one host or one embedder API. It's using some other user space API that has also declared itself as a host. How does this diagram work?
Are you sure you only want one thing from that? Because
no. So
from some APIs, I can imagine, like depending on what happens internally, you might get different results.
That's true, and you might want that one.
You
person
might want to know about that.
Well, and someone wants to test their API, so when they're testing, they want to see what happens internally, right? Differently from if they're showing it to client code, right? So this is sort of like a just my code question in the debugger.
So this is.
No, go ahead.
So there's in debuggers, they use a concept called black boxing.
Right.
That's relevant.
Just my code, yeah.
Or you get to define where the boundary is, right? So you showed me this information. This is not useful. Black box this for me, and from that point onwards, this is not a boundary for me anymore.
Right.
So here's how I was sort of thinking about this. You guys can tell me why I'm wrong, okay? But here, if I'm saying, wait 1 second and I'm going to pass a callback, I'm saying wait 2 seconds and I'm going to pass a callback, right? The contract here, right? It's not explicit, but the contract is this function that I'm passing in here, I'm passing in here, is a function that's going to be invoked asynchronously, right? And the parameter, right, or this specific function that I'm calling, right, takes this thing as a parameter, right? And so you've got this notion of like, okay, I've got function cd, right? It's going to do, hello.
And
right?
can we sort of put an implementation for wait 2 second there plus a pseudo embedder API?
Yeah. So wait 2 sec. Let's just do this. This guy's going to call, wait 1 sec. Actually, what would this look like?
Well, you do a link and a call.
This as a call picked it again. That was 1 sec.
Sorry, wait 1 sec dot what client? We want to call this twice, but okay. Go ahead. I won't write code on okay, there you go. Perfect. And then this guy's just calling it set timeout. So how I think about this is that this isn't just a function, right? But this, call it continuation. Is it special, right? And when you construct it, it's going to fire the link event, right? Tell me why it's wrong.
Sure. I mean, I think more like when you bind it, it's going to be linked, but it needs to be like a special kind of function before you bind it.
So what do you mean by bind?
Well, I mean, I think in the code that Kelvin wrote there, right?
No, what I'm saying is like down here, if I eventually say like, you know, here I say, you know, wait 2 seconds, right? Continuation, callback, right? At this point, I'm constructing this thing, right?
What, sure. I mean, let me put it this way. Let's say I have a function and the bind operation promotes it to a continuation.
Okay.
So let's sort of keep with that model to match our embedded API approach.
Okay. Sure.
Yes, but conceptually, yes, you could say that the constructor that you
sure.
unhappy.
Okay. Okay.
I don't necessarily agree with that. I think when you constructed the function may not necessarily be the right context. This is why it gets tricky. It's where the programmer intended to pass it as a continuation. That's when it becomes.
Okay, but you need a way for the programmer to signal that intent.
And there's no syntax for it.
Right.
Well, but that's where I think you're saying is like, hey, there's a bind
That
function.
bind is the syntax, is the demarcation. It's not syntax, but it's the demarcation.
And that's where I was saying, you know, yesterday is like, hey, you could drive a language construct into this such that there is a first class mechanism by which somebody can indicate their intent. But exactly, right? Let's go to the standards. But I think that the irrespective, right, it's like what we need, or one of the requirements is we need a way for the programmer to signal intent, right? I think that what you can do now is you can say that there's an API, bind, link, whatever it is that you want to call, right? But the programmer can do that, right? And that solves this question of, well, where are the boundaries? How does somebody look at this and then reason about it, right? Do you agree with that?
Yeah.
If you can come up with this language level construct, all our problems solved. I completely agree.
Yeah. I think it's there, right? Like, I mean, I don't think it's too much. I think, like, I don't know, I call it continuation, call it whatever it is you want. It's a function, it's special, right? I think in lieu of this, you've got, I don't know what you call it.
You want the annotation, right? Yeah.
Sure. Right, in lieu of it, you have an API, right, and it says link, and it takes a function, right, and it basically says, you know, if callback.link, right, then, you know, whatever, return, that is, it's already linked, right, else, you know, you've returned some other function, right? That's going to do.
Well, it's the continuation constructor.
Sure. Yeah. Effectively,
simplicity.
There's something like this, right? F is equal to that. F.link equals true, right? Return F, something like this, right? And then in here, you say raise link. And then, sorry, in here, you say raise link. Sorry if you guys can't read this, right? And here you say raise before, execute. Here you say raise end, execute. You've got some try catches, some error handling.
And the key thing from our discussion is that if you've already linked it, you don't relink it in a new context.
Bingo.
Right.
Yeah.
So,
but also the way you wrote it, the link and the execution, you put them in the same spot, and that's not what I would have expected. I think those are separate operations.
Sorry, the link happens here when you call link.
Okay,
the
there's
function that
an
gets
internal function.
returned.
Okay,
Yeah, so
got
this
it.
is f equals.
Okay, got it.
So that's kind of an implementation. Like,
Yeah, but I was
put
trying
it
to
together.
be
It's
concrete.
compact, yeah,
Yeah.
and concrete.
So 2 points about this. You just change this prompt to some connection pooling or user space queuing modules. It's they're doing it wrong. To JavaScript developers, you are all doing it wrong.
No, I didn't. Right? Because what you can then do is you can go into Node, you can find all the libraries, all the places where you got fs.read that takes a callback that you expect to be this first-class concept continuation, and you can say, the continuation is actually a linked thing, right? Link it for me. And then what you've done is you've gone into the library and you've explicitly said all the places you want these continuation points to be. And if somebody doesn't do this, if they do fs.read and they just pass in a function that doesn't have this special bit on it, right? Then the library will do the right thing. We'll fire the right event at the right time. We'll call into whatever dependent APIs, whatever stream APIs that expect a continuation, and they won't fire these unnecessary events.
So basically, this setup would give you good default behavior for not the vast majority of the cases. And then in some cases you had where the programmer explicitly wanted the context to come from outside the promise because they were using that to do lazy initialization. They could explicitly put a link event to change that behavior if they really wanted to and really knew what they were doing.
Right. So Node Core has already done this through async wrap, right? So async wrap is doing this exact operation. No?
Similar, yes. Right.
Yeah, I don't know that it necessarily is, right? It's not doing it.
So what is the difference?
It doesn't expose the way to do it for like user space modules.
Well, but this doesn't either, right? So somebody user space modules, somebody has to go do
well,
something.
and basically the user space module would say, when I have a contract that it implicitly says, oh, this parameter is the async parameter, explicitly they'd add this. I mean, this is basically the I forget what it was called for async hooks, the user space
embedder
the embedder API. Sorry about that. Just blank. Yeah, this is basically mirrors that embedder API concept.
Right. So I guess it's analogous. I don't see what the difference fundamentally is. Yeah.
Well, I think from my point of view, it's like what you need to do is you need to elevate the concept of where these continuations happen into, as close to the user code as possible, right? And you need to start sort of driving idiomatically, like, hey, you're calling this thing through here, it's a continuation, it's special, be special about it, right?
So I guess what you're saying is it's analog to async hooks, but you want to drive it through DC39 as a language construct.
Well,
I'm not saying that yet.
Hold on.
I'm saying that yet, right? I'm saying that if this proves useful and successful, then you've got a strong argument to go in and take to the standards body that this is how people should be thinking about this from a syntactic user code construct.
Sure, but you could make the same argument. If async hooks is useful, then you can make the same argument. And this is just a stepping stone in the middle.
Right. So basically what this says is, here is a concept that you want to express at any API that has asynchronous stuff, and you would do that by this explicit, demarcation of some behavior. Now, that's just to sort of make the semantics of what's going on explicit. In async hooks, they basically have the wrap objects internally, which can, potentially do this more efficiently, right? But that's the implementation choice on doing this in a different location. We're just trying to have the conceptual model clear about what an async boundary would be and why and how it would be demarcated and what the semantics of that demarcation would be.
Yeah, and the other thing I think that's interesting is that I think this, I believe, gives you a path to how you would expose such an API on down-level places, right? Where async is not.
It's a more elegant, less verbose, less sort of embedded API wordy kind of a way of doing things. It's more elegant.
I think they're rules in some sense.
It's language level, whereas the other one is an API.
Yeah.
Well,
so this is a special case of async resource because you will be forced. Async resource allows you to batch up all your callback calls, whereas this assumes that every single configuration is marked individually.
Yes, right.
So
Because
basically, if you just create n async resources for every callback, you basically have the same thing.
right. So like you said, this is just, we want to be explicit about what the semantics of an async call are. And then if there's a faster way to do the actual implementation, that's, that's fine. But then there's a clear definition of what it should mean when you do that optimization.
Now the gap, I think, with this is like where does cause events fire, right?
Yes, for most embedders, they would be at the same point, right?
Yeah.
Because you're just passing a function. There's no assembling some sort of promise tree or anything.
So for promises are the only one that require separate cause.
Well, and I think emitters as well.
Emitters, and you could make an argument. I'm not ready to make the argument. That the user space queuing problem should have a cause event pointing back to the thing that's driving. Well, I mean, I think you could probably point it at the previous thing that executed in the user queue, or you could point it back to the thing that's driving the user queue, right? And you would have a more complete view of the model when you want to traverse that or not. Now, how does that break some of the semantics? I don't know. Is that useful or necessary? I don't know. That's why I said I'm not ready to make the argument, but I'll throw it out.
Can you remind me again into like in this view, how would the user space queuing authors say that you're already linked, but that's not the right one I want to be good at? So what's the equivalent of the embedded API in that case? This kind of thing.
So you're saying that if I've authored a library, I'm expecting a function, I'm putting it in a queue, I'm going to fire it later.
Yeah.
Right? I think at the call point where the function is invoked, you would say if this thing isn't linked, link it.
Right.
So
Well,
you
I think
basically have
you're asking so our version is the higher level API always knows a better link context than the lower level API. And you're asking if I'm the lower level API and I disagree with you and I want to override that, how would I do that? I mean, there's an implementation. Is there an example where that makes sense though? Like that just does not seem.
Okay, I don't have to think hard, but let's say 2 user space queuing libraries.
Yeah.
And both of them are batching things, and there's batches of batches. And the lower level one says, no, actually, this was on behalf of something else that I just batched with stuff over here.
So I think that it's like you can solve that problem by just having additional properties on.
You have
function.
link and unlink, right? And cause and uncause.
Effectively, right? It's like you basically want to be able to say, hey, if something's been linked and it's been wrapped up in some mechanics, I basically want to be able to unpack it and rewrap it in something else that I'm aware of, right? So you just basically need to hang this original function passed in wherever this was on the return.
So actually, I don't know if my thing was contrived or not. I guess the main way to prove or disprove it is to articulate whether you can nest. The nesting has to be perfect or not. If nesting has to be perfect, then the scenario I described probably doesn't make sense.
So what do you mean by perfect?
Perfect means that like if I have an outer async and an inner async, like do they have to nest perfectly? So
Yeah, I think they do. I don't think that makes sense. I think they do to nest perfectly, right? I think it breaks. If this is the model for like the before and end execution, and you have some try-catch stuff in there, it's like yes, they have to nest perfectly, right? And I think if they didn't, I I've been wrong before, but I don't think that's, my gut's telling me it's that.
Yeah, I think our conformance says you have to have a nesting relationship in the execution events and link before cause and a few other things is the expected structure. And
So,
but if there's
just for clarity, can we just quickly recap what we are calling the user space thing? Is it? It's not link. It's like async node, or what is the?
Well, I think
So link is for user space between module, link would be to on a callback that you pass to the user space between module.
Yeah, and so what would be the return? The thing it returns what it.
Link returns a possibly different function.
Asynchronous continuation. Call it I mean,
Okay.
let's make the distinction between a function that's going to be invoked synchronously on my current stack versus a continuation, right? That's going to be invoked later on some different stack, right? And I think that's the key distinction. And I think that the trick is how does the user know where those points occur?
Yeah, and so in general, again, from my understanding, user queuing library would never queue functions. It would always put continuations into its.
Ship it?
I think you don't need this like CV value. If you link twice, then you just have to map.
Well, but I think the point is to get away from those cases where you're emitting a lot of noisy events or noisy data, right? And you want this sort of simplified model that kind of says, like, I know something's supposed to be a continuation. I know I'm passing it along some synchronous stack, right? But I don't care about wrapping it up multiple times in the same synchronous stack.
If you have a module that's interested in seeing how many times we use
I'm John. You can, we're going to for kind of wrap up and head back in.
Did we fix it? Like,
Finish what I was saying.
No,
what's
but
that?
yeah.
Finish what I was saying.
Yeah, sorry.
So I think this is a question about what's the desired user experience. It might be like we never want to show this noise, that just we can't see a scenario that's useful for this. It might be we'd like to support it, and you have a flag where you can turn it on and off, you know, from your library code or something. It might be a case, sort of the just my code or black box, where we'll record it, but we'll make it, you know, we'll flag which level it's on, so it's easy to shut off the intermediate steps for a module or not.
But you may have in one process, one module wants this view and the other module wants this view. Consider you have an APM inside and the clinic inside, which have completely different.
Yeah, but if that's the case, I guess I'd make an argument that that shouldn't be. Like, there should be one view of asynchronous call
But how can
paths.
you guarantee this
Well-
process?
Well, but that's I think the exercise.
Yeah, so-
Can we land on this sort of shared understanding, clear understanding, crisp definition about where these points happen, and then
Well,
everybody's
no,
like,
I think this
correct.
is a little different than the points. It's like maybe what you want to track and what you want to show, particularly from the user space queuing side, right? Which I think is more a question of what are the use cases and what's the aesthetic.
So, you were going to finish your point. Kelvin.
Yeah, I was just gonna say, like, if you have a module that counts how many times, or how long the time is spent in wait 2 seconds and wait. The whole kind of module. What should it give if I call it 2 seconds?
Sorry, what?
So I have a module that reports information on how long I was spent waiting 2 seconds.
By looking at all of the asynchronous executions along this path.
Yeah, and also tracks how much time I've been waiting 1 second.
Right, but I think what you would end up seeing is you'd end up seeing a graph that sort of has, you know, this is your first call to, you know, wait 1 second, and then you've got another call to, like, wait 1 second, and you would have these two nodes that you traverse in your graph that you then
So you wouldn't have this graph if you call in on the callback.
But you have another function here that would then be linked to that. Right?
Yeah.
So here you would end up with 2 link events and 2 callbacks with 2 begin end.
But I actually think you would either want 1 or 3, not 2.
1 or 3. Why 1 or 3?
Like you would want like.
Because you're eventually calling set timeout.
Because if you did this, you get 3,
right? If you did this, you would get.
You just wrap this callback. Like if basically if you have this, if you have a link function, not link again, and you call wait some seconds. Want to have a different example?
The function response. Callback. And those 1 second and 2 seconds, which means there is no other function. But this, if this links, let's say, data syntax,
sure,
and linked. So now it's linked at this point. It's passing the same function. The 2 things are also linked. So now this same instance of a function.
Yeah, that's a good point. That's a good point.
I think that getting rid of the noise is an interesting, but I'm not sure realistic goal.
Yeah, I agree. I think if you're like no one module operator to say what you want.
Especially if you pass those functions down into unknown, uncontrolled code, correctly annotating it in all cases will be very, very hard. You cannot, like, it's functions that might be executed more than once, and that is where the whole thing.
Yeah, but I wonder if you could do that again by just enhancing this link function to say, hey, I've got a function.
Yeah, but
as
for
it's
example,
been linked.
It would be possible to say just in the model there is a abstract operation which is get me my parent, which just automatically collapses series.
Yeah. Well, this is sort of Kelvin's. Oh, I just make a continuation of continuation, and then it gets popped the appropriate number of times in each continuation context, and then you can traverse the graph or the structure manually to filter it however you want, right? But at least that preserves the notion of which context you're in for each chunk, so you have clear differentiation for who is the top level, who is the lower level, and the strata.
We should probably get back to the other room. I don't know if there's necessarily any takeaways from this. Is there? Like, I mean, I kind of feel like we're having good discussions about the characteristics of what this model is and pros and cons. I think I think the key things here for me is how is it clear to the demarcation points, right? Did anybody else have any takeaways from this?
I really think we need to try and model something much more complicated with it, particularly something like what happens when you do an HTTP request would be good because it spins up like pooled objects and stuff that we haven't really discussed. I think that would probably be useful to model to see if it actually kind of like works with code that we already have.
I agree that would be a useful thing. I think there's some, cases if you look at the example stuff that we were looking at yesterday, where we took like some Express apps and mocked some stuff up, not fully consistent, but it's like, given a user's view of what the transition points are, this is what the model would look like.
I think the goal here again is from the spec view, we don't have to worry about pooled objects because we just have what does the user expect to see. And are we preserving that behavior appropriately with the contract the core API exposes?
you might sometimes want to actually see what's happening in the code.
True, but that's, you know, a deeper level thing where you actually care about the core of the implementation, right? And, you know, these nuances where at a high level for context tracking, you just need to know I created the HTTP request, I got it, you know, and then from there I spawn this file read, this timeout, this other thing, and then the request completed and trace it back to the original URI. You don't care whether there were pooled objects or there was some queue here or there, as long as you have all of those links in place to propagate the context information you care about.
I mean, that is true. The question is, does it make sense to express all those operations only on the highest level of the API? So for example, it is true, yes, that you can connect certain things on the high level APIs, and that might be the level of abstraction that most people care about. But at the same time, it means that if anybody uses lower level APIs, you either need them to separately also instrument those lower level APIs, or you lose context if someone happens to do something that is not using HTTP.
Well, you should always preserve context.
Yeah.
Right. The question is there context in the implementation at the lower level which you don't have fine-grained information on, which you may want to understand whether there was some blocking or non-blocking or some other behavior there, right? But I guess my viewpoint is we want to ensure that we preserve context as the user would see it, and at a way that's sort of simple to reason about. And then at the lower level implementation, if you have some of these details you care about, you can pull them out, but it's going to be specific to the way it was implemented. And the information you're going to want to express is specific to the way it was implemented, right? And it's closely tied to the way the code is set up, not the logical model that you want to present with what is async.
Yeah, but so I do agree that whatever acceptance tests we should have for async context or async hooks or whatever should always include and ensure that certain intuitions about higher level APIs are preserved. So for example, that if you have an HTTP request that maps to the normal intuitions about what the context preservation is. But I'm not sure that needs to be an API unless we want to, like, it feels more like an intermediate node in the graph than a replacement for the current graph. That makes sense.
Let me put it this way. I would like to specify what happens if we change the pooling, right? And you get rid of pooling on HTTP. Does that change? That changes the graph.
Yes.
Right. And that means that me as a user, I can't understand your API contract. I have to understand your implementation.
Okay,
right?
So like there's two graphs, right? There's the causal graph and the linked graph. Removing the pooling will change the causal graph, but it shouldn't change the linked graph.
Fine, but the semantics are still based on the implementation, not on the contract that the core library exposes.
Well, it depends on what you it depends on what you see as the contract.
Right,
But if you see as the contract that I'm making an HTTP request and my context is preserved between all the parts of it, then the contract is preserved.
Mm-hmm.
If you see and that was what I meant by an intermediate node in the graph. Like, we could totally say that we will insert artificial intermediate. So for example, let's make an HTTP request in the async resource, for example, which would mean that in the graph there would now be an async hooks thing that you are told about that is part of the public API, and you can totally then traverse the graph looking for well-known nodes that are documented and that are stable, that are part of an official API, and that are not tied to any implementation details of how exactly sockets are implemented, but it would still preserve the complete graph.
Sure, I guess that's the question. Does it make sense for users to know about async resources and hooks as part of the spec of the API? Because it's not there now, right? Like right now, I put a handler there and it gets called. And if I call other stuff from it, it's async and it propagates. There's no notion of a wrap or a pool or anything.
What do you mean, sorry?
Well, so you're saying that I would basically tell the user there's a pool, right? And async information propagates through this pool.
No, you would tell the user there is a graph of async operations, and here are the well-known async operations that you are allowed to rely on.
Okay.
Because
so
if you are in the middle of something, some third-party code that is free to add any kind of nodes intermediately that they want to, you wouldn't want to tie yourself to, hey, 2 levels up is the HTTP request at basically no point in time. So you will realistically, if you're looking for something specific, still traverse the graph up the causal or the linked chain.
Right.
But looking for something that identifies.
Right. But I guess the key thing is we want everything that appears in that graph to be, things that have a public contract in the Node core API, or an embedder has made public in their API.
Yeah. I mean, we can totally just expose a simplified graph, a public graph.
Yeah, that's
so
what
we can just hide all the intermediate nodes that are part of the public API and just collapse those.
Right. So that's sort of what we're saying here. Is like, what is this? What is a reasonable structure to present as a public thing?
Yeah, I think we are being
okay.
Right.
I'm just giving you the second time call. They're saying, hey, did you talk?